His mama. Yes, you can. I'm not that smart. All right, here we go. I've just been through a lot of years of schooling, so I know a little more. Doesn't mean I'm smarter than you. Well, not necessarily. You're just not as informed, but you could be smarter. Okay? All right, here we go. So today is really just one kind of new skill that we're going to learn. What we're going to do today is we're going to try to figure out what the measure of an angle is in the triangle versus what a side length is. So just reviewing real quick, last class period, you were given a right triangle. You were given maybe that this was 42 degrees. You were given that maybe this was 3, and they asked you to find x. What trig function would we use if we wanted to solve for x here? Sine. So the sine of 42 would equal what? 3 over x. Make sure you're with me here. This is super important because we'll be doing this today as well. So if I'm looking for a missing side, last class period, you said I take the angle they give me, the side I know, the side I don't know, and you pick which trig function to use. This is opposite. This is hypotenuse. SOHCAHTOA tells me to use sine. Sine of 42 is equal to opposite over hypotenuse. Did you catch in the video the little trick or shortcut when x is in the bottom? You just switch them. So you don't have to use that shortcut, but you can. We talked about putting this over 1 and cross multiplying. But now that you're getting good at that, you could just say anytime x is in the denominator, switch them. So now x is equal to 3 over the sine of 42. You grab your calculator. You make sure that it's in what mode? Degree mode. And then you type this in. Stop me right now if you are lost on anything I just did. Questions? Okay, this is what we did last class. What we're going to do today is, instead of them giving us the angle and looking for a side, they're going to give us 2 sides and ask us to find the angle. So for example, they may call it a Greek letter like we talked about last class period, maybe something like theta. And they may tell us this is 3 and this is 7, and they want us to figure out what theta is. So you're going to start out the same way. You're going to look at the angle you're trying to find, and you're going to label the 2 sides, but this time it's the 2 sides you know. So what would we call this side? Opposite. What would we call this side? Which means we would use which trig function? Sine. So we would do sine of theta equals what over what? 3 over 7. Now, our goal today is to solve for theta. What do you think you might do if you're looking at this and you want to solve for theta? What first comes to your mind? Okay, divide is what usually comes to a student's mind who hasn't seen the video. Maybe you caught in the video what to do. But a lot of students will say, well, we need to get rid of the sign, so we're going to divide by sign. Take your calculator, type in 3 divided by 7. We're going to do that in a second. Type in 3 divided by 7, and then do divided by sign. He's an ISS. Sorry. Sure. Okay, 3 divided by 7, divided by sign. What does it say? Error. Okay, it says error because you can't divide by a trig function without an angle with it. Remember, sine by itself means nothing. You have to have the angle with it. So what we're going to do is we're going to use inverse functions. And the bad thing about learning this in geometry is that you probably haven't talked about it yet in algebra. You can let me know if you guys talked about this in Algebra 1. But an inverse function undoes what another function does. So let's say, for example, I have y equals x plus 2. And that's my function. The inverse will undo that. So instead of adding 2, what's the inverse going to do? Subtract 2. So the inverse function would be y equals x minus 2. Did you guys talk about inverses in Algebra 1? Yes? Okay. So maybe you talked about it like f of x equals x plus 2. And then f inverse of x is equal to x minus 2. Good. Okay, awesome. If you did That's great. If you didn't, no big deal. What I need you to understand is that an inverse just basically undoes what another function does. Okay, and in Algebra 2, you're going to talk all about inverse functions. So what we're going to do is we're going to use the inverse sign, the inverse cosine, and the inverse tangent. We're going to undo what the sine is doing. So I want to show you how this works before we actually use it over here. So on your calculator, type in sine 30. What do you get? 0.5. So if we take the inverse, we should get back what we started with. So if I do the inverse sine of both sides, because whatever you do to one side, you have to do to the other. If we take the inverse sine of 0.5, try it on your calculator. Where's the inverse button? You do second sine, second cosine. So what's second sine of 0.5? 30. It takes you back to what you had. So the sine of 30 is 0.5. The inverse sine of 0.5 is 30. So the inverse undoes what the original function does. Does that make sense? So the inverse of sine cancels each other out. Okay? So if I'm trying to solve for theta over here, I need to undo the sine function. So to undo sine, I'm going to take the inverse of both sides. So I'll do the inverse sine on the left. Those will cancel each other out. And then I'll do the inverse sine on the right. Now type in inverse sine of 3/7 and tell me what you get. Christian says 25.38. Somebody agree? Okay. So theta is approximately 25.4 degrees. It's an angle measure, so it's going to be in degrees, right? Our calculator's in degree mode. We're calculating angle measures. Does that make sense? Questions? All right. Sorry, you're on the video, whether you wanted to be or not. She videoed. I know. I don't like it either. Me either. Okay, that's the goal today, to calculate the value of an angle. Here's where students make mistakes. When to use sine and when to use inverse sine. So when are we using inverse sine? To find the angle. If you're not finding an angle, you're not using the inverse. If you're finding an angle, what should your units be? Degrees. If you're finding a side length, then it's going to be relative to your problem. It might be inches, centimeters, meters, feet, miles, whatever your problem has. Today, we're going to be doing both, because today we're going to be solving right triangles. They're going to ask you to find everything missing in the triangle, so sides and angles. We're going to skip the first couple of examples and come back to them at the end. I'm also going to skip all of this stuff that's in your notes here and here. And I'm even going to skip this unless you feel like you need more practice typing on your calculator. Does anybody have a question on how to use their calculator for inverse? Okay, anybody have trouble want to pull out their phone and practice on their phone? Anybody? Okay, grab your phones or whatever device you're using at home. If you have a graphing calculator or a scientific calculator, grab it. If you're using your phone, grab it and try. It should be the same as what you were doing last class period. If you have to type in the number and then the cosine, it'll be the same idea for inverse. You'll type in the number, but then you'll do second cosine. I'll show you with mine. So look up here if you're having trouble. So first of all, remember your calculator needs to be in degree mode. Okay, look up here if you're not sure. This tells me my calculator's in degree mode because this changes it to radians. Right now I have sine, cosine, tangent, but I don't have an inverse sine, inverse cosine, inverse tangent. That's because I have to hit the second key before they change. Okay, so the first one was at 0.87. Yeah, so I would type in 0.87 and then second. And then notice that they all change to inverses. Inverse sine, inverse cosine, inverse tangent. So 0.87, and then second, and then the first one is cosine. Everybody getting 29.5 degrees? If you have a nice, awesome Samsung, then you type in second, cosine, and then 0.87. It does it in the right order. Anybody need help with their device? Okay, put those away then. Don't get distracted by your phones. And let's go back to the notes. All right. So we're going to jump right to this slide in your notes. So make sure you're with me and you're looking at this slide. Do you guys have this in your notes? Yes. Okay, here's what's important. If the directions say solve a triangle, to solve a triangle means to find all missing measures. So if the directions on the test say solve the triangle, that means find everything that's not given. How many angles are in a triangle? 3. How many sides? 3. That's 6 pieces of information. They're going to give you 3. 3. 3. Okay? So they're going to give you 3. It may be 2 angles and 1 side, or it may be 2 sides and 1 angle. But they're going to give you 3 pieces, and you're going to have to find the other 3. Okay? So for example, it says find the unknown measures. Be careful with your directions. This is weird, but they're going to change how you round. Round the lengths to the nearest hundredth. Round the angle measures to the nearest degree. What's it mean to round to the nearest degree? Nearest whole number. So angles are going to be rounded to the nearest whole number, but side lengths are going to be rounded to the nearest hundredth. Look at the picture. Notice that they give you one angle. What angle do they give you? S is 90 degrees. And then they give you 2 side lengths. So let's make a list of what we don't know. What do we not know? Okay, we need the measure of angle T. We need the measure of angle R. What else? ST. So you're going to have 3 answers on every one of these kinds of problems. Now there's 2 examples in your notes because it depends on what they give you to start with. Notice here I know 2 sides. What can we always use to find a missing side if we know 2 sides? Pythagorean theorem. But take a second and look at the other example in your notes. So it should be right down below. Do you guys see the example? Not directly below, but bottom left. They do not give you 2 sides, right? What do they give you 2 of? They give you 2 angles. So you're going to approach the second problem a little differently than you do this one. Okay. So on this one, we can find our missing side ST by doing Pythagorean theorem. So that's what I'm going to do first. I'm going to find ST. All right, help me out. What am I going to write down using Pythagorean theorem? 5 squared plus b squared. All right, let's do it. What's 5 squared? 25. What's 5.7 squared? 32.49. What do we do from there? Subtract 25. So b squared is equal to what? 7.49. What do we do to solve for b? Square root. So b is equal to the square root of 7.49. And our directions say round to the nearest hundredth for side lengths. So when you type that into your calculator, what do you get for ST? Somebody agree with JP, approximately 2.74? Everybody agree with that? Okay, are there any units on my picture for side lengths? No, so we would just say ST is approximately 2.74. Now, a couple warnings. I would not use a rounded answer to find another missing measurement. This is rounded, this is not exact. So never use a rounded answer to find another answer, because now your answers are getting more incorrect or more inaccurate. And 2, what if you had made a mistake here and you found ST and it was actually wrong? If you use that to find the angles, everything's going to be wrong, right? So it's better to miss one part of the question and then get the other parts right. So I wouldn't use an answer you found unless there's no other way to work the problem. Circle that, move on, come over here. Now we want to find either R or T, and this is new what we learned today. Do you want to find R first or T first? I heard R, so I'm going to say R. Sorry if you said T. So R, the way you're going to decide which trig function to use is to label the two sides you know. Don't use the side you don't know, or now you have two unknowns. You don't know what R is, so you have to know everything else. So what would we call 5 with respect to R? Adjacent. What would we call 5.7? Hypotenuse. Which trig function uses adjacent and hypotenuse? Cosine. So now we're going to do cosine of, what angle are we looking at? R, equals adjacent over hypotenuse. So what's our fraction going to be? 5 over 5.7. And today we said if we want to find an angle measure, what do we do to get the angle by itself? Inverse. So we're going to do the inverse cosine of both sides. When we do the inverse cosine on the left, it just cancels out the cosine. Then we do the inverse cosine on the right, and we get the measure of angle R is approximately. So nearest degree for angles, Christian says 29 degrees. Check and see if he's right. Preston says yes. Martin says yes. If you did not get 29 degrees, let me know. Questions? Doing second cosine 5 over 5.7. Making sure your calculator is in what mode? Degree mode. If it's not, you'll get the wrong answer. All right. Are we good, gentlemen? Okay. So we have measure of angle R is 29 degrees. We'll circle that. Here is the only time I will let you use a rounded answer. What do we know about all three angles in a triangle? They have to add to be 180. So if you already know that S is 90 and R is approximately 29, then you can use those two values and figure out angle T. You could also do another trig equation if you want to. But if you would rather, it's faster probably, you could find angle T by just using the fact that all three have to add to be 180. What's the fastest way to find angle T? 90 minus 29. You could do 90 plus 29 and subtract it from 180. But remember, if this is 90, the other two have to add to be 90. So the measure of angle T would be 90 minus 29, which is approximately what? 61 degrees. Why did I put approximately? Okay, the 29 is rounded. So even though 90 minus 29 is exactly 61, this is not really exactly 29. Does that make sense? Okay. So your goal today is to be able to solve a right triangle using inverses. Questions? Okay, look at the next one. On this one, can we start with Pythagorean theorem? Why not? We only know one side. What could we find here really easily, though? Angle D. So we need to know angle D. We could find it easily just by subtracting 58 from 90. So what's angle D? 32 degrees. And it's exactly 32 degrees because all of those values were exact. How are we going to find the missing sides EF and DF? When do we use inverses? When we're finding angles. So how am I going to find these side lengths? Okay, just what we did last class period. We're going to use SOHCAHTOA just like we did last class period here in black, but we're not using the inverses because we're not looking for angles. So you just pick one side to solve for and then pick for the other side to solve for. So which one do you want to do first? EF. Okay, so we're going to call that X. Remember last class period we labeled the side we were looking for and the side that we knew so that we only had one unknown. So if this is 58 degrees, what do we call this side? We're going to call it X, but is it the adjacent, opposite, or hypotenuse? Adjacent. And what do we call 14? Opposite. Again, notice I'm not labeling the hypotenuse because we're not looking for it yet. So which trig function uses adjacent and opposite? Tangent. So we'll do tangent 58 equals what over what? Careful. Opposite over adjacent, so 14 over x. And again, if you notice the little trick in the video, when x is down below, what do? You just, not flip, but you switch these two. Now, you don't have to use the trick if that's confusing. Do what we did last class period. Put it over 1, cross multiply. But if you recognize the little trick, you can just switch these two. So x is now equal to 14 over tangent 58. Plug it into your calculator, and again, remember, side links are rounded to the nearest hundredth according to the directions. One more time? 8.75. Everybody agree with Martin and Christian? Okay, and so that is EF. No units, but if there were feet, inches, miles, you would put those. Okay, again, I would not go to Pythagorean theorem now. Why would I not use Pythagorean theorem right now? Because that's rounded. And if you did this wrong, now you're going to get the next one wrong. So I would go back and do trig functions again. Let's call FDY this time. So when I'm looking at angle 58, what do I label the side with the y on it? Hypotenuse. So this time I'm not using the adjacent side. I'm using the hypotenuse and the opposite. So which trig function? Sine. So sine of 58 equals what over what? 14 over y. And once again, if the variable's down below, trick is just switch them. So y now equals 14 over sine 58. Plug it on your calculator. What do we get? 16.5 what? 1. Questions? I went pretty quick there. That is FD. So solving a triangle means to find all missing parts. Sometimes you'll start with Pythagorean theorem. Sometimes you'll start with triangle sum theorem. Then you'll use your trig ratios when needed. If you're finding a side, it's just like what we did. If it's an angle, you use the inverse. Any questions? Okay. Everybody needs a piece of graph paper. And you're going to need one for your homework, so make sure you have graph paper. Martin, will you grab me one too? Oh, never mind. I have one. Never mind. Actually, no, I don't, Martin. Thank you, sir. All right, look at the problem up here on the board. This should not be difficult. We're going to go really fast through this. This is just what we were doing, with one exception. Ladies and gentlemen, when you look at example number 4, it does not give you a picture. And the coordinates of the triangle are going to be placed on a piece of graph paper, which means they have not given you any information. No angles, no sides. But when you graph it, ultimately it should turn out to be what kind of triangle? A right triangle. And you should be able then to count the vertical and horizontal sides. So you'll be able to find 3 pieces of information very easily. And then you'll just do exactly what we did in the last 2 examples to find the rest. So on your graph paper, graph those coordinates. Make sure I'm graphing mine correctly. And definitely double check how you graphed it, because if you graph one point wrong, it messes everything up. So if you're going to double check anything, double check the coordinates as you graph them. And obviously, if it doesn't turn out to be a right triangle, you probably did something wrong at this point, since the whole chapter is about right triangles. Okay, which angle is the right angle? P. Again, if it says find all missing measurements, you have to list all 6 pieces now, because you don't have anything given to you. So on your answers over here, you're going to put measure of angle P equals 90 degrees. Don't forget the little m. Don't forget the degree symbol. What else can we find easily? PQ and PR. Count those. What's the distance from P to Q? Martin says 5. Somebody agree with Martin? Okay, so PQ is 5. Yep, we're just counting straight, vertical, horizontal, super easy. What's PR? Martin says 7. Somebody agree? All right. Dorothy says, yep, you're right. So now, there's a couple of things you could do. I heard somebody say distance formula. You could use distance formula if you want to. But what else could you use? You could do Pythagorean theorem to find RQ. So it's whatever you want to do, distance formula or Pythagorean theorem. I'm going to do Pythagorean theorem just because I think it's a little faster than distance formula. So if I do Pythagorean theorem to find RQ, what am I writing down? All right, I'm just listening to you guys talking. 5 squared plus 7 squared equals c squared. 5 squared is 25. 7 squared, 49. Add them together. What's 25 plus 49? 74 equals c squared. So what do? Square root. So c equals the square root of 74. Type it in. Again, your direction said round side links to the nearest hundredth. So what does that make RQ to the nearest hundredth? 8.60. All right. Notice I used approximate symbols. I had a professor in college who was super picky about that. If you used an equal sign, it had to be exact. If you used an approximation symbol, it should have been rounded. If you didn't do one or the other correctly, you missed points. I'm not that picky, but I will warn you that if you make a bad habit now and then you get to college and your professor is that picky, it's harder to break a bad habit. So be careful.
Like if it says rounded to the nearest hundred and it's 0, do we have to?
I won't count off either, but some teachers will. If it's to the nearest hundredth, you should have what that hundredth place is. Okay? All right, how do we find angles R or Q? Using what we learned today, our inverse trig functions. So do you want to do R first or Q first? Q, I heard. All right, so we're going to look for Q. Remember, you're labeling the sides you know. So what is PR compared to Q? Opposite. What is the side with the 5 on it compared to Q? Adjacent. Which trig function uses opposite and adjacent? Tangent. So now we're going to do tangent of Q equals what over what? Should be opposite over adjacent, which is 7 over 5. So what do we do today to get Q by itself? The inverse. So inverse tangent, inverse tangent. So now we have the inverse tangent of 7/5. We'll type that in on our calculator, and we'll get the measure of angle Q approximately to the nearest degree. What do you guys get? 54? What units? Degrees. And then remember, the only time you can use your rounded answer is when you're trying to find another angle measure, because all 3 have to add to be 180. So what could we do to find angle R? Just subtract 54 from 90. So what's 90 minus 54? 36 degrees. And it's still approximately because we rounded 54. Circle all 6 answers and you're done. That's a box. Questions? I went really quickly, so if you're lost anywhere, do not hesitate to ask. We're all good? For real? Ethan, you're good? Josh? Good? Sure? Zach? Good? Hallie? Okay, I got a lot of quiet people I'm checking on there. Any questions? All right. JP, are you good?
I'm good.
All right.
Yeah.
So we're going to skip the next one then because it's just another graph the triangle kind of problem.
Miss Lashley, you're gonna have to.
I can help Brennan later. I'll catch him up.
He's turning up. He's very cold.
All right. We have 2 more examples to go over and then we're done today, okay? And all of it is just applying what we just learned. So the next thing that they want you to see is how you can really use this in real life, okay? So one application of inverse trig functions is trying to figure out the steepness of a road. So if you're going up a hill or down a hill, that road has a specific steepness. In Algebra 1, you didn't call it, you did call it the steepness, but what did you call the steepness of a line? Slope. So what we're going to do today is talk about that idea of slope and apply it to a road, but using the terminology that you would see if you were in construction. They don't call it the slope of the road. They call it the steepness or the percent grade. So when you see percent grade, it's describing how steep the road is. If you've ever been traveling around on a road trip somewhere, you might see signs that are kind of warning signs. And on those signs, they'll tell you, like you can see where it's steep road, you can see a truck sometimes on the little road, but sometimes they have a percent sign. And if they have a percent sign, they're telling you that what the angle is, basically, that the road is making with the horizontal. But they're not really giving you the angle measure, they're giving you the percent grade. And you could calculate the angle measure. Okay, so what we're going to do is try to understand how does percent grade tell me the angle measure that the road is making with the horizontal. So if they say it's a 31.5% grade, what does that mean? So let's start with percent. Percent means something out of 100. So that means we have 31.5 out of 100. And if we're thinking about the road with the horizontal, what that means is if this is the percent grade, then that means that you're going to rise 31.5 feet for every 100 feet that you run. Because remember, steepness means rise over run. So on your picture, what that means is if this is your road, then your road is rising 31.5 feet for every 100 feet that you're running. So every 100 feet horizontally, the road goes up 31.5 feet vertically to create a slope that has a 31.5% grade. Does that make sense what I'm saying? So rise over run gives us the percentage of our grade. So what we want to figure out is how could we calculate this angle that it's actually making with the road? They say that it is 17.5 degrees. We could find that out on our own using our trig. If I'm looking for this angle, what would this side be called? Opposite. What would this side be called? Adjacent. And which trig function uses opposite and adjacent? Tangent. So we would write down tangent of theta equals what over what? Okay, stay with me. We would write this down with me, JP. Tangent of theta equals what over what? 31.5 over 100. Then what did we learn today to do to get theta by itself? Inverse. So we would take the inverse tangent of both sides. They would cancel on the left, leaving us with just theta. And then we would type in inverse tangent 31.5 divided by 100, and do you get about 17.5 degrees? Now that's the steepest street on Filbert Street in San Francisco, California. And you may not think that 17.5 degrees sounds very steep, but how many of you have ever ran on a treadmill and increased the incline to maybe even just 4 degrees? How many of you have ever ran on a treadmill and changed the incline? If you have and you increase the incline, it doesn't take much for it to get a little bit challenging, right? A 4-degree incline is not very much, but it makes you run harder. 6 degrees, 7 degrees, you make it 17.5 degrees, and you're probably not going to be running up that hill. You're probably going to be walking and dying trying to get up that hill, okay? So it doesn't sound like much, but it's pretty steep, okay? Questions on how we calculated the angle? All right, try the next one on your own. When you think you have an answer, write it down so I can see, and if you're having trouble, let me know. Careful, you're giving me an angle measure, so it's not going to be 4 feet. What's it going to be? There you go. Good. Good. What units do you have there? Good. It's not really multiplying. You're taking the inverse tangent of a fraction. So that's when you, on the board, when we did inverse sine, it's of our fraction. So whatever fraction goes in there. So you're plugging in your fraction, 7/100ths. Does that make sense? Okay. Okay, let's check it. So I'm seeing some good answers. I'm also seeing some people kind of not real sure. So if it's a 7% grade, that means 7 out of what? 100. That's also equal to, if that's the percent grade, that's the steepness of the road. So that's telling you the rise over the run. So when you think about drawing the road with the horizontal, they're asking for this angle measure. Create a right triangle by going straight down perpendicular, and then your rise would be 7 and your run would be 100. Which means you're using which trig function? Tangent. And you're always going to use tangent when you're doing these percent grade because you are given the rise and the run, which is always going to end up being the opposite and the adjacent. So you'll do tangent of theta equals 7/100. And then today we said to get theta by itself, we use the inverse tangent. And when you type that in to the nearest degree, what did you get? 4. Don't forget you're giving me an angle measure. It says to the nearest degree what angle. So that means this should be in degrees. Not feet, not inches, not miles. Be really careful. Questions? Ask now, otherwise I'm skipping the next example. Okay, go back to the beginning of your notes. We skipped 2 problems at the beginning. And then we're done. And freshmen, I would love to know tomorrow when you take the ACT Aspire, if you have any sine, cosine, tangent problems. So try to pay attention and come back to me and let me know on Thursday if you actually used your SOHCAHTOA at all or not, okay? I'd be curious to know. All right, last kind of problem. We are trying to figure out, it says use this trig ratio, cosine of A equals 24 over 25, to determine which angle of the triangle is angle A. Now there's a couple of ways you could work this problem. So I'm going to show you one way, and if you're confused, then I'll show you a different way, okay? But basically they want you to look at this picture, and there's two angles that are numbered, number 1 and number 2. And they want to know which of these angles, 1 or 2, must be angle A if when you take the cosine of it, your answer is 24/25. Are you with me so far? So what you're trying to do is you're trying to look at this picture and you're trying to find the cosine of angle 1 and you're trying to find the cosine of angle 2. And you're trying to figure out which one of them is 24/25. Are you following me so far? So start with cosine of angle 1. Cosine is which two sides? Adjacent and hypotenuse. So if I'm looking at angle 1, which one's the adjacent side? Which one's the hypotenuse? Okay, so you're going to compare 1.4 over 5, and you're going to see, is that 24/25? Two ways you could do that. You could just type in 24 divided by 25 on your calculator, and you could type in 1.4 over 5 on your calculator. And look and see, are they the same decimal? Are you following what I'm saying there? So type in 24 over 25, which should be 0.96, and then type in 1.4 over 5, which is equal to what? 0.28. Are those the same? No. So that means angle 1 is not angle A. Without a calculator, what could we do to this to make it the same denominator? Times by 5. So you could multiply this by 5 and this by 5, because it may be on the non-calculator part of the test. What's 5 times 5? What's 1.4 times 5? 7. So it is not 24 over 25, so that means angle 1 is not angle A. Does that make sense? Either without a calculator or with a calculator. Okay, if angle 1's not angle A, then which angle has to be angle A? 2, but we can check. But first we're going to go ahead and write down, I'm pretty sure the answer is angle 2. Now let's check. Which side is adjacent to angle 2? So that means this is going to be what over what? 4.8 over 5. Without my calculator, multiply both the top and the bottom by 5. We know that that gives us 25 on the bottom. What's 4.8 times 5? 24. And so we can see that they are the same number. Or you could type it in on your calculator, 4.8 divided by 5 and 24 divided by 25, and they should both be 0.96. Are you with me? Okay, so you see that the cosine of angle 2 is 24/25, which means angle 2 then must be angle A. Questions? All right, try the next one on your own. You got a 50-50 chance of getting it right. It's either angle 1 or angle 2. Oh, I'm sorry. I forgot. There's got to be a ratio. You can't work the problem. I'm so sorry. This is missing on your notes. My bad. I cut it off. That's not helpful. See? It's not that you're not smarter. You're just uninformed. Whenever you think you have an answer, write either angle 1 or angle 2 on your paper so I'll know that you have an answer. Be careful. Check with your neighbor, see if they agree with you.
Right there.
Hold on, we're going to check right now. Okay, raise your hand if you have an answer. Not that you want to shout it out loud, but you've had enough time, you have an answer. I won't call on you. Just raise your hand if you've had enough time. Okay. All right. Raise your hand if you think the answer is angle 1. Hands down. Raise your hand if you think it's angle 2. All right, we got some miscommunication. Be careful. Most people who picked angle 1 probably picked it because they did cosine like last time, but this one said sine. So sine is which two sides? Opposite and hypotenuse. So if I'm looking at angle 1, what's the opposite? What's the opposite? 27. What's the hypotenuse? 30.6. So you're checking to see is 27 over 30.6 the same as 8 over 17. And it is not the same. So then you go to angle 2, or you just go, well, obviously it's angle 2, and circle your answer. But you can check it. Opposite now is 14.4 divided by hypotenuse 30.6. And is that the same as 8/17? Yes. And if you do not understand what I'm talking about, the very first questions on the homework are like this. So get it out, get started. You've got about 12 minutes.